I'm Derek Harris here at HP Rice Development, and this is inside your WP Pro Component A-Kit forks. That's right, fellas. These are what everybody wants when they buy KTMs. We've already shown you what's inside KYBs, so we're going to show you what's inside these A-Kit WP Pro Component cone valve forks. So, real quick, this is your outer tube. This is your inner tube. This is your axle lug, which is billet and absolutely gorgeous. Okay, that's CNC machine, all billet. All right. And then here's our inner cartridge assembled currently. We'll disassemble it right here. That's obviously the spring because it is a spring fork. And then what I wanted to show you, and the reason I have this still together, this is the spring perch, and attached, the way it works is it slides up into here like that. And when you turn this big red cap, it can tension or loosen tension on that spring by moving the spring perch forward or back. Small increments, of course. So when you move this, very small increments, moves this perch in and out and can tension your spring like your shock body does. So that's kind of neat. So we're going to show you the insides of these cone valves here in a second. But real quick, just for reference, here's a Showa 49 set off of a 250 or 450 Honda bike. There's the spring perch. It's a little bit different. It doesn't have that tube that goes up to the cap because this cannot adjust the preload externally. If you want to change the preload, you got to change the length of the spring, or you can do it with shims either here or here in order to add tension. If you have to remove tension, you got to get a little more creative. Of course, it has the cartridge rod, the jam nut, and a cartridge assembly. Very similar in that department. So you have cartridge rod, jam nut, cartridge. And if you look, let's pull this spring off real quick. There's the bottoming lock. Okay, that little thing, that's what helps prevent bottoming. If we look at this Showa fork real quick, guess what? Bottoming lock. Exact same concept and technology. Nothing different there at all. One thing of note, this outer tube is considerably different than a stock WP outer tube. It does not have any taper. So from this mounting point on your lower triple clamps, the fork tube stays straight all the way to the seal assembly area. The stock ones taper thinner and they are softer or have more flex. These are much stiffer, they have less flex. However, unlike all these magazine guys who don't know what they're talking about because they don't know what they're talking about, they don't revalve, they're not engineers, and they truly have no idea on those concepts. They just are feel guys, which is fine. They feel certain things that are incorrect and correct. Because these fork tubes are stiffer, considerably stiffer, the vertical motion of your fork is smoother. What does that mean? That means that as that chrome tube is trying to go into this tube here, this tube is flexing less on big impacts. And as it flexes less, there's less friction. Because if this is bending, this tube doesn't want to go through it. And you guys have seen the videos where if you over tighten your hole shot device or over tighten your fork clamps, these tubes don't slide through because they have a tight tolerance. And that tight tolerance, if the fork is bent, is not going to allow that tube to go through. So these will actually have a plusher action. That means that this tube will more easily go through this tube. However, when you're on lean angle, when the bike is being deflected to the side in a direction or manner that is not moving that fork, not trying to compress the fork, just trying to flex the fork, these will be stiffer. And so there's a little bit of a difference there. If all you do is take this tube and put it on your current standard forks, on top of your current standard chrome tubes and internals without any other changes, you will notice a dramatic difference in the performance of your bike. Better or worse, that's up to you, but you will notice a dramatic difference in the performance of your bike by going to a much stiffer outer tube. All right, let's pull these things apart and let's take a look at the guts on how the valving works. Now the fork is apart and we can see the insides of this A-Kit WP cone valve. So let's take a quick look at what's going on. This base valve assembly has an ICS, interchamber spring. This is a separator piston, and then here's your base valve. This uses a very small base valve in comparison to KYB or Showa, but it's kind of par for the course for the former WP what we would call bladder forks. Very similar design to what those nitrogen-charged bladder forks were. What were those forks? Well, those were a twin chamber with the same piston design as this one, not a cone valve though. Similar base valve design with a base valve of this size, but instead of this spring, they used a bladder like your shock, and they used nitrogen in it. Everybody, quote unquote, hated that fork, but it's exactly what Del Saggio, whatever they are called, is selling now. And I mean exactly. I'm actually curious if they were the company that provided those forks to WP back in the day and then rebranded it, coated it so it looks like this, and now they sell them. Who knows? All I do know is that when you buy these A-kit forks, they're very, very similar to those old bladder forks. Now, there is one primary difference. KTM's the only only brand in the game that uses the Delta shims on the rebound side, which lets fluid in that port, that hole, a little bit easier than, say, a full round shim. So it's something they've always done. Their 85s have it. They do this on every fork. So this piston is nothing special. It's just a standard piston, but it's flattened on this side, perfectly flat. This is a cone valve adapter, and then this is the cone valve assembly here. We'll pull that apart here in a second for you to take a quick look at it. This is a top-out spring. This is what prevents your forks from clunking when they extend on rebound. As they extend, it hits that and it cushions that blow so that you don't hear it clunk on extension for rebound. It also changes your ride height just a little bit because when you have your fork spring in there, it's pushing up against this spring on extension. So the stiffer or softer the spring is, changes the very, very first inch of your fork a little bit. Now, let's take a look at this cone valve. One thing to note really quickly on this particular setup, this is set up in a way so that this spring is loose, it springs free, it spins easily and freely, it has a little bit of play. If you can look really closely there, it has a little bit of play. That's a similar concept as to having float on your shims. That means shims that have a float or non-clamped surface against the piston. That gives you initial little bit of free fluid flow until before you open the spring at all. And then as the fluid continues to increase in speed, it compresses or collapses that spring. This little blue thing in there is the actual piston, and it lifts off this cone valve adapter and opens up flow area for oil. Is a cone valve a heck of a lot different than a shim stack? No, they actually function very, very similarly, but there are a lot of things you can do with the cone valve that are hard to do with a shim stack. And so that's one of the reasons why they're used. There's other things that could be done uniquely with a cone valve that I have never seen done within the motocross industry, but there are very unique things that could be done with them that are somewhat used in other industries, especially mountain biking, where they have what they call smart shocks and smart forks. There's things you could do there that we're not seeing in the motocross industry, but I think you could easily see if somebody wanted to put the time in on this. So let's take this cone valve apart and you can look at that. There is the cone valve laid out. So this is a special post. You have to have a post like this for this cone valve design. We sell a cone valve adaptation kit to your WP air forks. It makes your air fork a cone valve. We put a post on like this that's custom to our setup. We put a piece like this that goes in there. What this piece does is it matches up against this piston right here like this. So you have those holes, they line up perfectly with those holes. It goes like that, and then you have the cone. Here's the cone. They have different quote unquote colors available from WP, which is different angles to the cone. And then that cone sits and goes in there like that and blocks off any fluid from coming out. And then as it opens, it does this against this spring right here. That spring is the resistance to that cone, okay? So it sits like that. Let me get it all laid out, kind of like this. And then there's the piston and then the rebound shims. So this cone's in there like that. It moves up and down on this shaft right here. That's the resistance, that spring right there. It's a coil spring. It's pretty stiff. And then you have these shims. What do those shims do? They set the tension on the spring or lack thereof. So right now the spring has no tension on it in the installed position, which means it has a little bit of free gap, which means that cone can float just a little bit off that gold cone assembly or cone seating assembly. This piston has been used, actually I believe this is a direct pull out from a couple other forks they have, including the Explorer fork. I'd have to go grab one and double check that, but this part number is nothing special. You can adapt cone valves to KYBs if you wanted to. If you built this little stem post and put these components and parts in there, boom, you would have a cone valve KYB. So nothing really too special about it. It's all about what it can or can't do to your damping. And that's what a lot of people miss when it comes to suspension. There's no really cool or secretive stuff. Damping is the resistance to movement. That's all it is. So it doesn't matter how you want to do that. You have to create a resistance to that movement. And then you can get creative about how you want that to look. So if you wanted something that was linear, this is a very linear combination. This spring is a linear spring, and that means you're going to get an equal resistance to an equal increase in movement. So if we push it a little faster, we're going to get an increase in resistance. If we go a little slower, we get a decrease in resistance. A shim stack does the same thing. And I actually believe this has a little bit worse response time because this has more mass than a shim stack does. That's neither here nor there, but it is something that you could manipulate to get certain unique results that, like we said, with smart suspension, like in mountain bikes. Imagine if this was a little bit modified, then all of a sudden you have something that has inertia to it, which then plays its own role in suspension response. So here's the base valve. It's got a shim stack on it. Nothing special. This base valve has been around for a long time from them. It is aluminum and it's nice and lightweight. It's DLC coated on this shaft. That's good for sliding. That's DLC coated. That's good for sliding. That's DLC coated. That's good for sliding. All of those things are nice. And of course, it's very lightweight. This is very light compared to KYB or Showa, but it's very small. Now, what does small do or mean? It changes the relationship between velocities and fluid flow through that piston. Talk about this piston diameter size a little bit. It's very important, and I'll tell you why. When this shaft is moving, it's displacing fluid. That fluid has to go in through the cartridge up into here, and then it goes through that piston, and then it pushes up on this separator piston. When you have, for example, like this, say this is 4 times the area that this is, then you have a 4-to-1 reduction in speed of the fluid. So the fluid's moving at, let's say, a speed of 4. It would be moving at a speed of 1 through this piston. That reduces the amount of damping you have, because damping is a product of velocity. That's the only thing damping cares about, is fluid damping, is velocity. So when we have a 4-to-1 reduction, that means we have a 4x reduction in velocity, we get a 4-time reduction in damping through this piston. KYB and Showa are huge pistons. They might have a 10-to-1 reduction in flow area. That means that they have a 10-to-1 reduction in damping force if you're doing the exact same stiffness of shim stack. And this is important because there's a relationship, like a ratio, between shaft speed and fluid velocity through the piston. So when this moves 10 meters per second on here, you might get a 2.5 meter per second velocity fluid flow, which means your range of velocity fluid flow through this piston is 0, not moving, to 2.5 meters per second. On a Showa or KYB, you would say, okay, we're doing 10 meters per second with this shaft, but we have a 10-to-1 reduction. So we have a 1 meter per second fluid flow velocity through this piston. And that means that our range is 0 to 1 meter per second. That's a big difference in range, and the total amount of damping you can create is different between those setups. But there's also a component of leverage, which is hydraulics, which is kind of neat too. So anyway, that's an inside look at the WP cone valve A-kit forks. Beautiful forks, well made, nice stuff. Probably not as secretive as you guys thought it was. And if you really start racking your brain on how damping works, you might start wondering why somebody would use a cone over shim stacks. If you truly understand how shim stacks work and you truly understand how this works, then you'd say, I don't know if there's much of a difference. And there kind of sort of isn't. But there are things you can do with this setup that are very hard to do with shim stacks. For example, I could just add shims here and preload that spring. I now have a preloaded damping setup very quickly and very easily. Kind of hard to do on shim stacks. And it's very easy to adjust. I just add some shims of various thicknesses here and boom, I've got more preload. Shim stacks, it's very hard to do that in an effective manner. So some things that you have to look at. All right, thank you guys for watching. I'll see you next time on the HP Race Development YouTube channel.